Hi students, today we are going to study about external communication interfaces. The interfaces that we are using to connect an embedded system to the external world. So external communication devices are otherwise called product level communication interfaces. Okay, so it is responsible for data transfer between the embedded system and other devices or modules. Okay, so the external communication interfaces are classified into two. One is wired communication interface and the second one is wireless communication interface. Wired communication interface examples are RS-232 and USB. And wireless communication interfaces are infrared, Wi-Fi, Bluetooth, Zigbee and Gprs. So one by one we will discuss. So RS-232 is a standard that is developed by Electronic Industry Association to interconnect these computers and other devices. Okay, so it is a full duplex system, it is a wired system, and it is having an asynchronous serial communication interface. Okay, it is having an asynchronous serial communication interface. Okay, so inside the computer we have a UART, universal asynchronous receiver transmitter. That same signal will be transmitted to the external device. So we can say like RS-232 is an extension of UART communication. Okay, so in UART what we are using? We will using standard TTL or CMOS logic. Okay, so normally high represents 1 and low represents 0. Okay, but in RS-232 we uses EIA standard for bit transmission. Okay, so as per EIA standard, a logic 0 is represented by plus 3 to plus 25 volt. Okay, and logic 1 is represented by using minus 3 to minus 25 volt. So we need a converter to convert from TTL or CMOS logic to EIA logic. Okay, so these are the connectors. So we have a 25 pin RS-232 connector, or 9 pin connector is also there. Okay, we can transmit the data, request to send, then clear to send. Okay, that is an acknowledgement that is given from the other device. Then data set ready, ground signal. Okay, then data carrier detect, then transmit clock, then receive clock. These are the signals that are present in 25 pin connector. Okay, so we have a small 9 pin connector also. So if you look into the back side of your computer, you can see a 9 pin connector, that is a DB9M connector. Okay, so what are the 9 pins? One is DCD, that is data carrier detector, then RX receiver, TX transmitter, then DTR. So what is DTR? Data terminal ready. Then ground, then DSR. Okay, then RTS signal. Okay, request to send. Then CTS signal, clear to send. Okay, so these are the signals that are present. Okay, so if you look into the connection, you can see we have a data terminal equipment. Okay, data terminal equipment, that is our device. So it will be connected to a modem. Okay, then the modem will be connected to the telephone line. Okay, and at the other end, okay, so why I am saying the other end? Because both ends are transceivers. This is transceiver 1 and this is transceiver 2. Okay, both transceivers are connected using a modem and connected to a telephone line. Okay, So here you see data terminal equipment DTE. Okay, it is connected to a modem. So the transmitter is connected to a receiver, and the receiver is connected to the transmitter, and ground is there. Okay. So the transmitted signal will be received by the modem and it will be transmitted, and again the received signal is given to the next transceiver. Okay, so this is the operation that is happening in RS-232. Next is universal serial bus. So all of you have seen this universal serial buses. Okay, so this is a standard device that we are using. So what is the purpose of universal serial bus? We can connect printers, mobile devices, any devices we can connect it to our computer using universal serial bus. Okay, it is like that we can connect any devices to an embedded system also using this universal serial bus standard. So what is a universal serial bus? So it is a external bus standard. Okay, so it will allow connection of peripheral devices. So we can connect peripheral devices to the embedded system or a computer. Okay, so it connects devices like keyboard, mouse, scanners, printers, joysticks, audio devices, disk devices, etc. Okay, so the data transfer is 480 Mbps. Okay, 480. So it facilitates the data transfer at the rate 480 kbps, 12 Mbps or 1.5 Mbps. These are the standard data rate. Okay, so this is developed by a group of companies. Okay, that developed company is called Special it is developed by Special Interest Group. Okay, so this special interest group consists of Intel, Microsoft, Compaq, DEC, IBM. So as you see, we can connect this pen drive or this USB drive to any devices. Okay, irrespective of the company, we can connect this device to this pen drive or printers or scanners to any devices, whether it is an Apple, whether it is an IBM PC, whether it is a Microsoft PC. So it doesn't matter, we can connect this device to any computer. Okay, so the lowest speed is 10 to 100 kbps, and so maximum signaling rate is 1.5 Mbps. Okay, the full speed is 500 kbps to 10 Mbps or 12 Mbps. Okay, the highest speed that is provided by USB 2 is 400 Mbps. So now we have a USB 3 and USB 4 also available nowadays, because they are upgrading the software and hardware daily. So those devices that are compatible with the USB 4, it will provide a higher speed. Okay, so and these devices are back compatible also, that is it will be compatible with the previous versions also. Okay, so that is the importance of USB devices. Okay, so it is called a USB, Universal Serial Bus. Okay, as the name indicates, the data transfer happens using serial communication. Bit by bit it will transmit. Next one is infrared. Okay, so what is infrared? So it is a certain region in the light spectrum, that is we cannot see infrared rays. Okay, but it is having some good properties. It is having higher wavelength, and the wavelength ranges from 0.7 nanometer to 0.7 micrometer to 100 micrometer or 0.1 millimeter. Okay, so this infrared is again divided based on the frequency, like a near infrared, mid-range infrared and far infrared. Okay, so normally we are using this infrared for measuring the heat. Okay, as you can see, nowadays we are having thermal scanners, right? Okay, it will be in the shape of a gun. Okay, so if you go to airport or if you go to railway station, they will use this thermal uh, sensing devices. Okay, and we can sense temperature. Okay, so that is one application of what infrared. So first of all, the transmitted signal is modulated using a carrier frequency of 36 to 46 kilohertz. Okay, very small frequency. Okay, then the infrared LED will oscillate at this frequency for the time of this pulse. Okay, the information are pulse width modulated and are contained in this 38 kilohertz frequency. Okay, so what is the type of modulation that we are using here? Pulse width modulation. Okay, so the data rate that is supported by this IR is 9600 bits per second to 115.2 kilobits per second. Okay, so for medium infrared it is 0.576 Mbps to 1.152 Mbps. Okay, so in the case of fast infrared it is 4 Mbps. Okay, so the main problem with this infrared is it is a line of sight communication. Okay, so this signal cannot travel a long distance. Next one is Bluetooth technology. Okay, so Bluetooth, as we know, what is a Bluetooth? Okay, the Bluetooth is a wireless technology that is used for short distance communication. So the maximum range will be like some 10 meters or 20 meters like that. Okay, so it uses ultra high frequency, that is 2.4 to 2.485 gigahertz for exchanging the data. So it is developed by the telecom vendor named Ericsson in 1994. Okay, so it was actually first introduced as a alternative to this RS-232. Okay, RS-232 is a wired form of data transmission, and this one is wireless. Okay, so this Bluetooth uses a radio technology called a frequency hopping spread spectrum. Okay, so using this frequency hopping spread spectrum, it will transmit the data and receive the data. Okay, so a master Bluetooth device can communicate with the maximum 7 devices. So why it is called a master? Because this master will only share the clock. The clock generated by the master will be used by the other devices. That's why it is called a master. Next is Wi-Fi protocol. Okay, so what is Wi-Fi? What is the full form of Wi-Fi? Wireless fidelity. So Wi-Fi uses radio waves to provide a wireless high-speed internet and network connections. So we can connect the internet to a Wi-Fi device, and this Wi-Fi device will can act as a router or a hub. Okay, so the standard IEEE standard that is used by this wireless Wi-Fi is IEEE 802.11. Okay, so this Wi-Fi is intended for network communication and it supports IP. What is IP? Internet Protocol. So in order to communicate in Wi-Fi, we need an intermediate device that is called a Wi-Fi router. Okay, so this Wi-Fi router is responsible for restricting the access to the network, assigning IP address to the incoming devices, okay, routing the data packets to the corresponding device. Okay, so we can control this using a password. Okay, so in order to provide a security to this Wi-Fi communication system, we can provide a password. Okay, so we have some security mechanisms. So the security mechanisms that are available in the Wi-Fi are wireless equivalency protocol, that is WEP. Okay, then wireless protected access, that is WPA, etc. So if you take your mobile phone and if you look into the Wi-Fi settings, you can see all these things. Okay, wireless equivalency protocol, wireless protocol access. Okay, these things you can see in your mobile phone also. Okay, so if you are making your mobile phone as a Wi-Fi hotspot. Okay, these are some security mechanisms supported by Wi-Fi networks in data communication. Next is Zigbee. Zigbee is another protocol. So it is also used for creating a personal area network. Okay, so we can create a personal area network without the interference of wires. Okay, normally how we will connect a company systems in a company, we will use LAN connectors, right? So without using this LAN connector, we can simply use the Zigbee technology or Wi-Fi technology to interconnect the devices, just like LAN. So the Zigbee is using the standard IEEE standard 802.15.4. Okay, so it is used for creating personal area networks. Okay, so the features of this Zigbee are, it is having a low power, low data rate, and close proximity. Okay, and it is used for creating wireless ad hoc networks. Ad hoc means temporary networks. Okay, so these applications include wireless light switches, electrical meters, in-home displays, traffic management system, etc. These are the applications of Zigbee. Okay, so since it is having low power consumption, the range will vary from 10 to 100 meters. That is the maximum range of Zigbee. Okay, so depending on the power that we are giving to the devices. Okay, so this is one connection of Zigbee. Okay, so we have different devices. We have a name for different devices that we are connecting to the Zigbee. Okay, one is Zigbee coordinator. Okay, so it will act as a root of the Zigbee network, and it is responsible for initiating the Zigbee network and storing information. Next one is Sigbir Router. It is responsible for passing information from device to another device or to another Zigbee router. Okay, Zigbee routers are displayed as blue color. Okay, and Zigbee coordinators are orange color. Okay, then the thing that is having yellow color is Zigbee end device. Okay, that is our device that is in our hand. Okay, this end device containing Zigbee functionality for data communication. It can talk only with the Zigbee routers or Zigbee coordinators, and it does not having a capability to act as a mediator for transferring data from one device to another. Only Zigbee router and Zigbee coordinator can route or coordinate the data or control the data. Okay, the end device can only transmit or receive. That's it. Okay, so the Zigbee supports an operating distance of 100 meters and the data rate is like 20 to 250 kbps. Next is Gprs. Okay, General Packet Radio Service. That is the initial form of that data communication that we used in our mobile phones. Okay, so Gprs is packet radio oriented mobile data service on the 2G or 3G cellular communication system. Okay, that is used in our GSM mobiles. Okay, so it was actually formed by European Telecommunication Standard Institute, ETSI. Okay, so GPRS usually is typically charged based on the volume of data that is transferred. Okay, so if you look into this system, so what are the connections we have? We have a GPRS device. Okay, this is directly connected to the tower or base station. Okay, then there is a GPRS network will be there, then GPRS gateway will be there, and in the GPRS gateway only we will provide the internet. This internet is accessed using this GPRS modem or GPRS handset. Okay, so these are the four services that can be provided by GPRS. Okay, so one is, so GPRS can extend the GSM packet circuit switching data capability and make the following services possible. So it can provide services such as SMS messaging and broadcasting. Okay, always on internet access. Okay, next is multimedia messaging services. Then push to talk over cellular. Then instant messaging and presence wireless village internet protocol applications for smart devices. Okay, that can be accessed used to WAP wireless application protocol. Then point to point service, internetworking with the IP. So we are using GPRS network and we can connect this network to the IP, that is internet. Okay, and we can provide the service to the customers. Okay, then point to multi-point. Okay, so multicasting. Okay, we can transmit the data or signals and it can be accessed by different people. That is also possible. So these are the services that are provided by GPRS. Okay, so we studied about a external communication interface, that we are connecting this embedded system or a computer to external devices that are present outside the embedded system or the computer. Okay, so we studied about two types of communication, that is wired communication and wireless communication. Okay, so thank you for listening to this lecture.